Today we will solve the problem 8.19 of Griffith Introduction to Quantum Mechanics, third edition. The problem is find the lowest found on the ground state of hydrogen you can get using the Gaussian trial wave function. Here they have given the trial wave function which is Gaussian in nature, which is equal to e power minus p r square. Here a is the normalization constant and p is the adjustable parameter. So you will get the answer. Answer also they have given is minus 11.5 electron volt. Actually, for hydrogen atom, ground state energy is 13.6 electron volt. So which is closer to this value. Now, first you find the normalization constant. For that, you have to integrate psi star psi, which must be equal to 1. Here, you remember that it's a three-dimensional one, so it is a volume integral. So that t tau, you can see the t tau. So t tau is by definition r squared sin theta t theta t pi t r. This is the t tau. Then you can integrate this. This integral will become three separate part. Uh, that is a squared you have taken. First you differentiate between 0 to 2 pi t pi. Pi is pi angular pi is 2 pi, and similarly theta is 0 to pi. So you integrate sin theta t theta between the limit 0 to pi. Uh, so the remaining radial part is e power minus 2 p r squared into this r squared uh, and dr. Now you can, if you integrate this, you will get 2 pi. Answer of this is this first integral is you will get pi. If you apply the limit 2 pi by 0, then you will get simply 2 pi. And integral between the sine theta. This is 0 to 5. Sine theta t theta is equal to 2. That is very simply we can argue that if you integrate sine theta, you will get minus cos theta. Minus cos theta. Then if you apply upper limit, cos pi is minus 1. So that will become uh, if you apply the limit 0 to pi, within the bracket you apply the upper limit. That is cos 0 is cos pi is minus 1 and cos 0 is 1. So minus of minus 1 you will get minus 2. Already there is minus outside, so this will become plus 2. That is the, now you can notice that integral is not between minus infinite to plus infinite because of the spherically symmetric one, and also this pi theta angle will take care of it. So 0 one particular direction, pi is another direction, it will take care. So only thing you have to remember is this integral is limit is between 0 to infinite. Here the limit is actually minus infinite to plus infinite. Because of symmetry, it becomes 0 to infinite, and we are taking care of the angle also. So nothing will change here. Now I can say this is modulus a squared 2 pi into 2 is equal to 4 pi. Hereafter, I am going to take it granted that integral of sine theta t theta t pi is 4 pi. Straight away, you can take it. It's always true. So then this integral 0 to infinite e power minus 2 p r squared TR is equal to 1. So we got this expression. Here you take this integral. It is a Gaussian integral. So you can solve it using the Gaussian integral, using payment method of solving Gaussian integration. So we have already seen in detail about the Gaussian integral. I have given the link in the description box. You can kindly refer it. That is integral minus between integral between minus infinite to plus infinite r squared e power minus alpha r squared dr is equal to half square root of pi alpha power minus 3 by 2. Here I am taking 2p as alpha. This 2p as alpha. 2p as alpha. Then you substitute uh, this into the integral. You remember that this integral is 0 to infinite. This is minus infinite to plus infinite. So this is 2 times that of this integral. You have to remember. So now if you integrate and it's a standard integration, you just take the output. So this is equal to modulus a squared and this 4 pi. The value of this integral is 1 over 2 square root of pi. Alpha here is p 2p. So 2p whole power minus 3 by 2. Since this integral is integral is between minus infinite to plus infinite. This is half of this integral value. So I have introduced one half, that is 1 over 2. Now you can simplify this. You can cancel this 4 with this 2 into 2. Get cancelled. Now you will get modulus a squared pi, this pi and the square root of pi, 2p whole power minus 3 by 2, which must be equal to 1. Now, square root of pi into pi is equal to pi 3 by pi power 3 by 2. So, I have combined these two terms. This is equal to pi divided by 2 p whole power 3 by 2, which must be equal to 1, or modulus a square. When you bring this to the other side, it will get inverse. That is 2p over pi whole power 3 by 2. Now our next task is we have to uh, find the expectation value of the kinetic energy. So for that you use the kinetic energy operator, which I have shown in the red color bond, that is minus h cross squared over 2m, here del square. Here it's your wave function. So trial wave function e power minus p r squared is your trial wave function, and you are taking volume integral, so this terms comes. Uh, at the beginning itself, I told that the value of sin theta t theta t pi is 4 pi. So you take that 4 pi outside this integral, which I have taken. So this will become, and then simply r squared. This r squared will not come under this del square operator. This is different. So only this psi del squared psi only. So to avoid confusion, I have taken this r squared in front. So this will become r squared e power minus p r squared del squared e power minus p r squared dr. Then we will see how it's going to be simplified. Now we got this expression. So the ultimate aim is we have to calculate the value of this del squared operator, del squared, that exponential. So this del squared operator in radial coordinate system is I have shown in the green color bond in the right hand side. 1 over r squared t by t r, r squared t by t r. I have used full derivative because here only r dependent. And of course, del squared psi. Psi is e power minus p r square. Now you solve the differentiate this wave function with respect to r. If you differentiate this with respect to r, you will get minus 2pr, then that exponential term e power minus p r square. So already there is one r square is here. Then this will become r square into r cube. So this will become minus 2p r cube. Then this exponential term you will get. Now we have differentiated only the exponential term. And here there is one r squared also we have multiplied with this. Now another derivative, you have to differentiate this entire term inside the bracket. So the terms inside the bracket is just now we have seen minus 2p r cube e power minus p r squared. Now uh, you take minus 2p outside. So minus 2p if you take outside because it's a constant. Already outside there is 1 over r squared. This will become minus 2p over r squared, and t by t r of this one. Sorry, this ended. This is r cube e power, because we have taken minus 2p outside. You have to differentiate these two terms. First, you keep differentiate r squared and keep exponential term as it is. If you differentiate r cube, you will get 3r squared, and you keep the exponential term as it is. Of course, you have minus 2p over r squared. Then uh, you keep r cube as it is and differentiate the exponential term. So I am keeping r cube as it is and differentiating this exponential term. If you differentiate that exponential term, I will get minus 2pr, then that exponential term e power minus pr square. So now there is r cube here. So already r cube here. So if you multiply r cube with r, you will get r4. Already you have 2p minus 2p r power 4 e power minus p r square. So now you have a exponential term as common in the both the term. So then you take it out. Then this will become minus 2p over r squared, 3r squared minus 2p r power 4 e power minus p r squared. Now you substitute this in here. Substitute this here. First, you simplify the terms outside the bracket. This 2 and 4 will get cancelled. You will get 2. So in the numerator, you have 2 pi h cross squared. 2 pi is there, 2 pi h cross squared over m, because 2 got cancelled. And here, then you have minus, and here you have minus. Minus of minus will become plus. Then you replace del squared e power minus p r squared by this term. Uh, that is here you have 1 over r squared. So I have taken this is 1 over r squared, 3r squared minus 2p r power 4, then this exponential term. Remember that you have r squared at the front. So that r squared will get cancelled with this r squared. So, and also all are real number, no imaginary part, so you can bring this here. So this will become e power minus 2p r squared multiplied by this 3r squared minus 2p power 4 2p r power 4 tr. Now we have to solve this integration. Now we have to solve this integral. We can separate this into two portions. First, 3r squared e exponential term. So 3 I can take out because it's a constant. So r squared e power minus 2p r squared t r. Then second term minus 2p I can take out. Here it will r power 4 will go inside. Then exponential term e power minus 2p r squared dr. Now, this integral, value of this integral, we have seen just now at the beginning of my lecture is equal to this one. When we are finding the normalization constant, this integral is equal to 1 over 4 square root of pi 2p whole power minus 3 by 2 we have seen. Then what about the second one? Second one, you can use the Gaussian integral. I have given the detailed lecture about Gaussian integral. So you please refer. That is very important. So if you integrate between minus infinite to plus infinite, x power 4 e power minus alpha x squared dx, you will get the result 3 over 4 square root of pi alpha power minus pi by 2. So here you apply. Here x is r replaced by r. So this is you will get it. Already there is 2p. Here also 2p. Then here 3 by 4. That I have explained. Here limit is 0 to infinite. So you divide by 2. So 3 by 4 divide by 2 will become 3 by 8. Then this square root of pi. Then alpha is replaced by 2p and power minus pi by 2. So to avoid the confusion, I will erase all these things. That is, I will erase this thing. Now we are going to eliminate some of the term. You can see I can write this 2p whole power 3 by 2 divided by pi power 3 by 2 can be written as pi into square root of pi. Now what are the possible thing we can eliminate? We can eliminate this pi and this pi, and similarly this square root of pi inside you can eliminate this square root of pi. Then here you have 2 h cross squared 2 h cross squared m. In the numerator you got the terms 2 h cross squared over m into 2p. Then you bring this inside 2p whole power 3 by 2 to inside the bracket. Then what will happen is the first term 2p plus 3 by 2 into 2p minus 3 by 2 will become 1. This will become 1. Here, when you multiply this 2p power minus pi by 2 into 2p power plus 3 pi by 2, you will get here 2p inverse. This will become 1 minus power minus 1. So this term actually we brought inside. So this also will get cancelled. So now you got only 2 h cross squared over m and this 2p. Inside the bracket you have 3 by 4. All other terms are eliminated. Then here you have 2p and this 2 will get cancelled with this 8. So you will get 4. So p into 3 by 4, then 2p power my whole power minus 1. Now what I'm going to do is 3 by 2 here you have 3 by 2, here 3 by 2, you take 3 by 2 outside. Then this will become inside the bracket 1 minus p, this p, 2p power minus 1. So 2p power minus 1, p into 2p power minus 1 is 2p1. You will get 2p. So pp will get cancelled. This will become simply off. 1 minus off is off. So similarly, here you can see uh, this 4 will get cancelled. This 2 and 2. 2 into 2, 4 will get cancelled to this 4 with this 4. So you will get 3 by 2. Here 1 by 2, 3 you have outside the bracket. So you will get inside the bracket 1 over 2 and this 4 will get cancelled. You will get only h cross squared over m into p into 3. So inside bracket it is half. So 3 multiplied by half is 3 by 2 h cross squared p this p over m. So we got the expectation value of the kinetic energy. Now we can find the expectation value of the potential energy. For hydrogen atom, the potential energy is minus E squared over 4 pi epsilon naught 1 over R, which I have given in the red color band. And R is a variable I have given, I brought this inside the bracket. Now, as usual, the if you integrate this sine theta t theta t pi, you will get 4 pi. So I have taken 4 pi outside. When you are taking the volume integration, this limit will change from 0 to infinite. Instead of minus infinite to plus infinite, it is 0 to infinite. And 4 pi I brought outside the integral, and a squared, modulus a squared is, we have seen 2p divided by pi whole power 3 by 2. Now this integral, we have to find this integral between the limit 0 to infinite. What I am going to do is you keep, sorry, 1 minute. You keep 2pr as u. Then what you will get if you differentiate this, uh, sorry, 2pr squared, because here you have 2pr squared. Then du is equal to this r squared. If you differentiate, you will get 2r. So 2 into 2, you will get 4p r dr. Then what is r dr? R into dr is equal to du divided by 4p. Limit will not change. If r is 0, u also 0. If r is infinite, u also infinite. Now r dr is, we are easily eliminating r dr. R dr is equal to 1 over 4. 1 over 4p, 1 over 4p into tu. Tu I am keeping inside. Then 2p r squared is u. So I am using this e power minus u tu. I have changed this. And as usual, I have expanded this. 2p whole power 3 by 2 is 2p into square root of 2p. Similarly, pi power 3 by 2 is pi into square root of pi. Of course, this e squared divided by 4 pi epsilon naught 4 pi. I have taken. and this 1 over 4 pi also I have given as it is. Then what is this integral value? If you integrate e power minus u, you will get minus e power minus u. That is very important. So if you apply the limit, what will happen if you apply the upper limit? E power minus infinite is 0. E power 0 is minus 1. E power 0 is 1. So minus 1. Already there is minus outside. So this will become, this integral is simply 1. This is 1. So now you simplify this term. Uh, that is, if you simplify this term, what are the term will get eliminated? This I will use different color. This 2p will get cancelled with this 4p. It will, you will get only 2. And then what else will get cancelled? This pi will get cancelled with this pi, and also this 2, 4 will get cancelled with this 2. So this can be written as 2. So now what are the terms inside in the numerator? You got 2 square root of 2p e squared. Of course, e squared divided by 4 pi epsilon naught. And here pi will get eliminated. So you will get simply square root of pi alone. So uh, this is the Hamiltonian. Hamiltonian is sum of potential energy and sorry, sum of kinetic energy plus potential energy. So this is kinetic energy, expectation value of kinetic energy, which I have shown in blue color. This is potential energy, which I have shown in the red color. So now you differentiate in order to find the minimum energy. You differentiate with respect to adjustable parameter p. So if you differentiate with respect to p, first term differentiate with p with p is 1. So this will become 3 h cross squared over 2m. And if you differentiate here, here is some interesting thing. What will happen to this square root of p? We can write this square root of p as p power of. So if you differentiate this, you will get uh, of p power of minus 1. That is p power minus half. So I have brought this p to the denominator, from numerator to denominator, and because it is half, this 2 will get cancelled with this half. So finally I will get the square root of 2 divided by square root of pi by p, and this term e squared over 4 pi epsilon naught, which must be equal to 0. This must be equal to 0. See here, it is, you can bring this term to the other side, it will become plus minus. And you can find out p. P contain only this term. And substitute p in the Hamiltonian here, and you can find the value. This is only the numerical substitution. You can find it is equal to, exactly equal to 11.5, which is closer to the ground state energy of the hydrogen atom. Thank you very much for watching my video and supporting me continuously. Thank you very much.